Hi everyone and welcome. This course is about blockchain and it's designed for beginners. Today we're going to be introducing the concept of blockchain and we're also going to have a look at some actual code to understand how blockchain is able to detect frauds. A blockchain is a list of records called blocks linked to one another using cryptography. Each block contains the hash of the previous one. So this block contains its own hash here, the second line, while the next block, as you can see, contains the same hash, which means that contains the hash of the previous block. Now here, as you can see, the first line is 0 because that's the first block of the blockchain. So it doesn't have any previous one, right? Also, we have a timestamp and a data. Now, in real life, a blockchain will be much more complicated, but that's good enough to give you a rough idea of how blockchain is structured. Blockchains are designed to be resistant to modification of data, and that's their main job basically. They are usually used in peer-to-peer networks where all participating nodes need to agree on the communication protocol and the block's validating algorithm. Once created, nodes can be modified only if all subsequent nodes are modified too, which requires consensus of the network majority. Blockchains are used by most cryptocurrencies to record transactions. They're used by smart contracts, and that's a big one. They're used by the financial industry to store data in a distributed manner, can be used by the medical industry to store patients' data in a distributed and secure way, which means that blockchains do not have to store currency. You can build any sort of blockchain. Let's try to implement something. That's my blockchain.js, which obviously is a JavaScript file. Now I'm importing this library over here because I need to calculate an hash. Now I'm creating the block class and the blockchain class. So you're gonna have a blockchain containing multiple blocks. So that's the constructor for the block. I have an index because it makes it easier to keep track of the blocks. A timestamp, by definition, you need one. And then we have the data. You also need some data. And then again, as we've seen before, we need to have the hash of the previous block and the hash of the current block. In here, I calculate the hash considering a string which consists of the index, and then I'm appending the timestamp and then the previous hash, and then the data, right? And then that's my hash, the current hash. And the blockchain class. So with the constructor, we are creating the first block of the blockchain, which is also called Genesis block. As you can see, the index is 0, and then we increment the index that the blockchain used to keep track of the blocks. Now these, we already seen this, we use this to create the Genesis block, which is the first block of the blockchain. This is going to return the latest block which has been created, right? Now, with this one, we insert new blocks. So we have that the new block has to have the hash of the previous one, right? That's the property that keep track of the hash of the previous block, right? Now here we calculate the hash of this block, the new block that's been inserted, and we store it into this property over here. Here we insert the block into the blockchain, and here we increment the index ready for the next block for being inserted. With this one, we get the available index, and this actually is the check that makes sure that there is no fraud going on. How does it work? Well, very simple. We have a cycle, and then if the current block hash is different from the current block hash, which is obtained by rerunning the hashing function, or if the value of the hash of the previous block, which is stored inside the current block dot phash, is different from the actual previous block dot hash. So if this link is basically broken, because these two are supposed to be equal, then you return false. Otherwise, if these two are true, you need to return true because it means that the blockchain is still valid. No one has been tampering with the blockchain, right? And that's the actual execution of the code. We create a blockchain and then we insert three blocks. The index is being automatically calculated, right? And then we print something. This is going to print the whole blockchain. Null means that we're basically printing everything, and two means that we are just using two blank spaces. And then here we are checking for integrity. And then here we are actually manually changing the data containing one of the block. And then we change also the hash. And then when we run the isTemperedWith function, we're going to be checking whether the blockchain is able to detect that the blockchain is no longer valid. Let's see what happens when we actually run the code. Okay, so we need to do npm init, and let's accept all defaults. It's gonna be fine, yes. Okay. And then we have to do the install. We need this. Okay. And now we can run it. Okay. So here it's printing out the whole blockchain, and then we are running the first check and it's passing. And then here we are doing the tampering, and then again this time the blockchain is able to pick up that the blockchain is no longer valid. Somebody has been tampering with the blockchain, right? Let's have a look at the code once again. So here I'm creating my three nodes, and then that's the first printout, the printout that is displaying the whole blockchain, and then that's the first check, and I'm passing this one. But then here, when I change the data and I also recalculate the hash, then this time the blockchain is going to pick up the fact that probably there was a fraud going on. And that will be all for today. I hope you've enjoyed my class. Please like my video and subscribe. And thank you very much.